Hello. Today we will discuss about the how actually the linked list is created and display. Okay, I have already in the last class I have displayed what I have presented what is the linked list and why you are using the linked list. Now I will explain how the linked list will be created. In very simple method I have done. First I have declared structures. Here you see this is the structures. This is the structures and which has two parts. One is the data part and another is the next part. Next part means pointer part. It's storing the address. And now you see I have created three nodes: head, second, and third. Head, second, and third. Three nodes are created. In the main function, you see what is written: head, second, third. Three variables first created, then three nodes are created. That means three different memory locations are allocated. Head is equal to stock node start malloc size of stock node means already one created, one memory is created or one node is created, and head is a variable assigned to it. Okay, head variable is assigned to it. Now you see again similarly we have written second stock node in star malloc size of stock node. That means second node is created. Similarly third node is also created. Now you see how I am storing the data. Head data is equal to 1 and head data is equal to 1. Head data is equal to 1 means what? Head data 1 means that is in the data part we are storing 1. We are storing 1. Here I am able to store 1. Now in the next part what I will store? That means I want to link this node to this node. That means address of this node to be kept here. What is the address? Address is second. That means we have to write head next is equal to second. Same thing is written. You see head second is head next is equal to second. Head next is equal to second. See head next is equal to second. That means link first node with the second. Link first node with the second. Clear? Similarly I can store the data here and I want to make a link. I want to make a link like this. That means what I will do? I will store the address of the third node. Address of the third node here. That means in the next part of the second. What I will write? Second next is equal to third. So same thing is written. Second next is equal to third. You see second next is equal to third. Second next is equal to third. And I have also stored a data. Second data is equal to 2. Third data is equal to 3. Similarly third next. What we will store? Third next, you see. Third next. Third next. That means in the next part of third. Is there any other node whose address we will keep here? No, there is no node. That's why here we will store null. Here we will store null. That means third next equal to null. Third next is equal to null. It is written third next is equal to null. Third next is equal to null. Then print list head. How we are printing the linked list. And printing the linked list I have already discussed in the your last one video. Okay, how I am printing the list. Printing list means I am just these are linked, the nodes are linked and I am just printing. Suppose the nodes are linked like this and I am going to print. I am going to print. What is the beginning address? Beginning address is the head. Okay, I will move to the one node forward and print the data. Same thing is written. You see what it is written. While n not equal to null, print percentage n data. What is n? N is the head. In the actual parameters we have passed what, whose address? Whose address? We have passed head address. Print list head. That means the same value having the your n. N is the same value. That means head storing the address of the head node. So we have written while n not equal to null, print n data. N is equal to n next. Then that means your pointer actually moving from one step forward. Suppose here this is the n, this is the n, because now the actual parameter is formal parameter is n. Actual parameter is head, but formal parameter is n. That means we are moving n to one step forward always in every iteration till n is reached here. Same thing we are writing here. See, while n not equal to null, we are moving printing percentage d n data, and n is equal to n next. We are moving n is equal to n next. You see, first is n is pointing to this. In the next step, n is pointing to this one. N is next pointing to this one. And in the next part, n is also pointing to this part. In the next part, in the last, n is pointing to this. N is pointing to this means null. When it is pointing to null, then it will stop automatically, because the coding is written like this. While n not equal to null, we have written while n not equal to null, you do that. Percentage d n data, n is equal to n next. N will move one step forward till your n is reaching null. So your data is now printed. That is 1, 2, 3. Okay. Thank you.